What's the problem with science? I'm going to tell you my top 5. Hey there, science fans. Dr. Kiki from This Week in Science here for D News. I'm used to talking about all the things that are awe-worthy about science, but science is not perfect, and everyone should understand how. So here's my list of the big problems in scientific research. 1. Convenience bias. Across the board, we lack a complete picture of the world around us because of a convenience bias in scientific research. Typically, researchers are only able to study animals in the wild when and where animals are there, and when the scientists have the time to get into the field. Thanks to an academic research schedule where researchers are teaching and students are schooling during majority of the year, most research is being carried out during single seasons rather than year-round. And a recent analysis of over 2,000 animal studies published in major journals over 18 years found that only 5% of them looked at how multiple seasons interacted to affect an animal's biology. Additionally, there is a vast overrepresentation of male subjects compared to females in the animal literature, because males don't have babies. Or because researchers haven't collected enough animals for an analysis to be statistically significant, studies don't differentiate between the sexes at all. Hopefully this sex problem will change moving into the future, since the NIH has called for better balancing of male and female subject numbers in studies. Number 2, sex bias. While we're at it, there are still more men in science than women. Yes, more and more females are studying in the sciences than ever before, but the people in charge are still mainly men. The culture of the scientific endeavor continues to favor men, as more men than women are still hired for academic jobs beyond graduate school, and more men than women are published in prestigious journals. And the craziest point here, both men and women in the sciences are to blame, as both sexes favor men 2-to-1 in situations like hiring. Okay, number 3, publication bias. Publication bias is the preference that some journals show for publishing scientific research that will be perceived as exciting, will therefore get cited as a reference by more people, and be considered impactful. It turns out that these journals also have higher retraction rates and publish studies that are less replicable. They sure might be exciting to learn about, but over time, as more data gets collected, high-profile studies turn out to be more like statistical coincidences. Number 4, results bias. The publisher-perish ethic among scientists had led to heavy competition to get published in the leading journals. Those who do manage to get published can look forward to many career benefits. So it's not hard to see how, with the drive to publish impactful research, researchers often overlook negative results that could be quite informative, or go so far as to cherry-pick data for their analyses. Those are extreme examples, but combined with personal unconscious biases, we're seeing a large number of retractions in recent years and a decline in reproducibility of studies. Also, scientists who are still trying to cement their careers are less likely to do studies that try to replicate the results of others. There's no glory in being second in science, even though it helps the entire scientific community. Finally, 5, money bias. All this brings us to how science is funded. In the United States, money can come from either the public, the government, or private sources, industry or charities. Changes to political priorities have left less than 8% of researchers who apply for government funding actually receiving it. Additionally, basic research that could lead to long-term technological and economic gains is being underfunded, as government grants emphasize practical research with more immediate and conceivable payoffs. To make up for shortfalls from public funding, researchers look for private funding, which can lead to conflicts of interest that bias studies. When the funding just can't be found, investigators have to downsize their labs and research efforts, and this means less good science being done. I know all of this sounds pretty bad, but it can be fixed. People within the scientific research community are already working to improve the publication process, find new solutions to funding scientific research like crowdfunding, and remove human bias from experiments. My advice to you: be patient with the process, continue to be awestruck by science when it's deserved, and always be skeptical of the extraordinary. Do you think I missed anything? What do you think of my list? Tell us in the comments below, or you can find me on Twitter at Dr. Kiki, and be sure to subscribe to D News for more science every day.